So, let us start the lecture number 8 of this module 2, and today I will discuss about the 3-4 valve conduction, especially we will go for the various valve voltages and the output voltages for both rectification and inverter operation. Then we will see how the commutation current is changing from 1 to 3 for all the 3 periods, and then later on we derive an expression in terms of DC voltage and the current along with the commutation reactance or resistance. So, the first one to draw the valve voltage, once your circuit becomes more and more complex, means you are going for the 3-4 valve conduction mode, or even though you are operating in the 2-3 valve conduction mode, but your alpha is very high and at the same time your this U is also high, means you are very near to 2-3 valve conduction mode. At that time the complexity arises. So, it is better to draw a table first, and then you will find in the table just you can write it what is the conduction valves. So, you can write the conduction valves, then you can write the from to means angle, from then which angle it will be conducting, this period will be from which to which, then what will be your DC voltage, or you can say output DC voltage, and then if required, if you want to draw any valve voltage, then you see what will be the valve voltage. So, these elements of the table will be very easily, and then you have to find and quickly you can mark it. Otherwise, what will happen if you are going for this sinusoidal and then you are saying okay, this is fire, and then you are going here, there you are again coming back, if you are doing any mistake, so you will not get your complete output voltage. So, this is valid for all the cases, it is whether it is a perfect 2 valves conduction mode, or you are going to 2 to 3 valve conduction mode or 3 to 4 conduction mode. Because in the 2 valve conduction mode it was very simple, we draw it directly here, but once you are going for 2-3 valve conduction, and especially you are going in the inverter operation, even though in 2-3 valve conduction it is required, or I can say it is desirable to draw the table and then you find where you are. Now, we are here going to discuss again 3 to 4 valves conduction, where your U is greater than 60 degree, and in this we know alpha should be your greater than these degrees. Already we proved in the last turn that U must be greater than 30 degree, and here we are talking about the 3-4 valves conduction mode, means your U is greater than 60 degree. Now, to draw the rectification operation, so first case is I am going to draw for rectifier, and we are going to draw the valve voltage here, I want to see it is 3. So, if it is asked 1, 2 whatever, just you write this, and based on this you can see what will be the voltage. So, you can make this table for complete cycle, then go here in the graph, and then you can just mark the points and then find the voltages, and you can trace it easily. Now, here we are talking about the rectifier. So, it will be given to you what will be the alpha and what will be your U. So, alpha should be here more than 30 degree. So, let us take alpha is your 45 degree and your U is your 75 degree. I am taking alpha is 45 degree, or it is better we can go for the 60 degree also, but let us take this value and then we have to derive. Now, in this we are going to have some condition where 3 valves were conducting, and sometimes we will have 4 valves where will be conducting. Now, you know what will be the period of this. This will conduct for U minus 60. So, this will be 15 degree, this U minus 60 15 degree, and this pattern is every 60 degree. So, the remaining here it will be your 45 degree. So, we know whenever the 3 valves will be coming, it will go up to 45 degree, and when it is 4 valves, then it will go for the 15 degree. This is the duration we are talking. Here the instant we are talking. Now, here again we are going to start when you are going to give the pulse to 3. You can start from anywhere, but throughout our lecture we have taken the 3 as a just commutating. This means 1 and 2 are conducting. In this case 6, 1, 2 will be conducting, and we are giving the gate pulse to 3 and it is going to conduct. So, in this case also we will start. Now, since I have taken alpha is 45 degree and we are giving the gate pulse to 3. So, here we are starting from 45 degree. Before that, here we are talking the valve 3 is getting pulse. So, this is the case when the valve 3 is getting pulse. We are starting from valve 3. So, here now and it will conduct because it is a more than 30 degree. So, here I can say 6, 1, 2 were conducting earlier, now 3 is going to conduct. Okay. So, we are starting from here, the 45 degree alpha is delayed, and here now earlier the 6, 1, 2 were there, now the 3 got the pulse and the positive voltage is arising, it will conduct. Now, this will go for 15 degree. So, here it will be up to 60 degree because the 4 valve conduction mode. So, from 45 this, and your output voltage will be 0, because always in the 4 valve it is a dead DC short circuit and it is 0. Valve 3 we are since conducting, so it will be also 0. Now, this will go only up to 60. At this 60 instant here, this will be your commutation between 6 and 2 will take place and the 6 will off. So, now 1, 2, 1, 2, 3 will be there, and now it will go for 45 degree. At this here you are going to 105 degree, and now what will be the DC voltage? In the DC voltage, now you have to see what is the DC voltage. Even though this 1, 2 and 3 are conducting, it is similar to when the 2 and 3 valve were conducting and the 3 valves were there at that time. So, it will be the same voltage, and just you can see from this graph, simply you can say 1 and 3 on the top. So, it will be A and C, B here. So, it will be minus C, and this is minus C to 1.5 here, minus 1.5 EC will be appearing. Okay. From there also you can justify it, because again for this at least I can explain 1 and 3 are conducting. So, voltage here EA, here EB. So, the total here minus EC by 2, and this is 2 is here. So, it is your minus EC by 2 minus EC, it is 1.5 EC which I have written here, and of course 3 is conducting, it will be 0. Now, then we can write all the here the patterns till we will arrive again back to here, then it will be a complete cycle. So, here now the 4 will get the pulse. So, 1, 2, 3, 4, then we can write 2, 3, 4, then I can write 2, 3, 4, 5. So, then we will have 3, 4, 5, then again we are having 3, 4, 5, 6, here we are going to 4, 5, 6, here 4, 5, 6, 1, here we are going to be 5, 6, 1, then we are going to be 5, 6, 1, 2, and then here 6, 1, 2, and from here again we are back to here. Is okay? Now, since the end of this here period will be the starting period of this. So, here it will be 105. Once again you must be very careful in adding the angles, means there this is a 45 degree. So, suppose you are doing any mistake here anywhere here, it will be continuously going to be recurring, and then finally you will get something absurd output voltage. So, 105 here, now this will go for 15 degree, because always you say the duration of this is your 15 degree and this duration is your 45 degree. We have already written there. So, now you add here the 15 degree means 120 degree, and the voltage will be 0, and here it will be also 0 because 3 is still there. So, you can now continuously you can write and see what we are going to get. So, here it is 120, then it is your 45. So, 165, I can write 165 here, then 15, it is 180. Here we are going to get 1, we are going to add 45 here. So, it is a 225, sorry, it is 180, we are adding 225 here, 225 to add 15 degree, and then it will be 240, and here from 240 to 285, and from 285 to here you are adding this is a 300, and from here 300 to we are going to have 345, and from here 345 to 50 it is a 360, and here where there is any mistake. So, it is 360 to 45 degree, again we are back here, or you can add here that is here 45 degree, because this is 0, and again you are going to that. So, we are just coming back and finally we are getting. So, you can see also from if you are doing any mistake, you can see if you are not getting 360 degree means there is some problem somewhere. Now, let us see the voltage. It is again how to draw here the 3 valves. So, all the force here will be 0. So, I can write here 0 output voltage we are writing, here it will be 0, here 0, here it will be 0. Now, in 2, 3, 4 you can see it is a 2 and 4 are the bottom. So, this is your C, here A, so B, and this is a B. So, here plus 1.5 E B. Now, you can see here this is a 3 and 5. So, it is a minus E A, and here. So, it is a minus 1.5 E A. So, here it will be plus. You can also see we are getting some symmetricity. So, plus and minus this is there, and you can see it is a C, B, A, and again we are going to get the here 4, 5. So, it is your 5 is C. So, it is 1.5 E C, here minus 1.5 E B, and here plus 1.5 E A, and then again this is. To see the valve voltage again, now we have to see 3 is here is conducting. So, it will be 0. Here this 3 is also there, then it is 0. Here 3 is there, so it is 0. Here 3 is there, then it is again 0. Now, at this case 3 is off, and now we have to see the voltage. Now, here 4, 5, 6 you see they are conducting, means the voltage and 5 is there. So, what will be voltage? Here you see the 4 and 6 are conducting. So, the voltage here is becoming minus E C by 2, and this side is E C is appearing. So, this voltage minus this. So, minus 1.5 E C. So, here it is minus 1.5 E C. Now, when 5, 6, 1 are conducting, what will be voltage? It will be dead short circuit here, voltage here will be 0, because whenever the 4 valve is the dead short circuit, here almost short circuit, the voltage here it will be 0. So, it will be 0 here at this point. Now, we have to see here, because the DC short circuit is just, you can say this is A, B, C phases are short circuited, all the 3 phases here. So, what will be voltage here? There will be no voltage, it will be 0. Now, we will see 5, 6, 1, what will be voltage? Now, the short circuit is removed, and 5, 6, 1 here means your is the EB, and here it is your already it is your EB by 2, 1.5 EB. So, you can see what we are getting just opposite to this. So, here plus 1.5 EB, here 0, here I can say 1.5 EA, just check it. So, this table is very convenient to draw, and this is the best way I can tell you. Otherwise, if you are always you are starting from here without drawing here, you are gone. So, now let us see and draw for this case on this graph and where we are getting. So, to draw the output voltage and as well as the voltages across any of the valve, we have to draw the line voltage on the graph, and here we are taking, since we are starting with the 3. So, the commutation voltage of 3, just it is EBA, and then we have to write other phasor voltages here, the line to line again it is CB, here it is your EAC, and again we are going to have EBA here. Now, we can see this is EBA, so it is your AB, just reverse of this, here it is your reversal of this, so ECA, here it will be your EBC, and the remaining here we are getting here EBC, and this is a complete line to line voltage. Based on this line voltage, we can, below one figure can be represented as your phasor voltages, and this is your EB, this one is your EC, this one is your EA, this one is your again EB. Means your, this is your minus EA, this one is your minus EB, and this one is your minus EC, and this curve is your again here, is correct? Yeah, it is correct here, and minus EA, here we are getting this EC. Why it is drawn? That's just we will see the intersection of this one is this. So, the voltage here it will be appear 1.5 of EB. You can see it is in phase with this here phase voltage, and here it will be, we can see it, the voltage will be 1.5 EB here. Now, we have to mark the angles. Angles, I said alpha is 45 degree, and you know this here it is 60. So, in between here it is your 30, and then in between here it is your 45 degree. So, this will be your, here I can say it is your 45 degree, and here your valve 3 is getting pulse. Okay. Now, after that here you see the output voltage becomes 0. So, we are starting here, the output voltage here is going to be 0 for 15 degree, and the 15 is up to here. So, it is means this is your 60, this is your, just you can mark, and then it is your, the output voltage here, it is here, first it is 0, as already you can see. We are drawing here first the output voltage, the DC output instantaneous voltage here. So, here it is 0. Now, we will see after that we are going to search for 1.5 EC, that is a minus sign, and this will be where is that? It is a several way we can find. This is basically positive, here it is 1.5 EC. You can also see here the minus of we are searching, minus here, this will be minus, sorry, is looking there? No, this is a minus, you see. So, this will be here, it will be coming here all the way to in between, there is a 30 degree phase shift, and this will go like this. Okay. So, here now the voltage is going to be, this value is your minus 1.5 EC. So, what happens, suddenly the voltage will go here and it will follow this one when the commutation is basically between 2 and 6 is over. So, suddenly here it was, I said it is your 15 degree, it is when the your 6, 1, 2, 3 are conducting. So, after that here commutation of the lower limb is gone off. So, it is suddenly following, this is a minus 1.5 EC. then it will continue, and then we have to find another after 60 degree, because this will go for 45 degree. So, the 45 degree here, this was 30 degree. So, it will go up to here, and this is your output voltage up to this period. Okay? Because this is the complete is your 60 degree. So, here it is always this portion we are here is a 60 degree. So, this is 30 degree, and this is remaining 15 degree it will conduct. So, it is a 45 degree, and it is going to be here, as I said 3 valves are there. Now, we are giving pulse to 4. We can also see from here onwards it is going to be 60 degree, and here basically your valve 4 is being given pulse. Then your output voltage becomes again 0, and here this we are coming here, and this will go for 15 degree. Now, once this will go up to here 15 degree. Now, this is a commutation between your, we have reached here, 4 is given, the commutation between your 1 and 4 is over, and now we are having 2, 3, 4, and then we have to see the voltage, and that voltage is 1.5 EB, and you see this 1.5 EB is nothing but it is going all the way here. So, it will be here, it will be coming here the voltage, and then it will follow this one, and it will again go for 45 degree here till this value, where it is we are giving this pulse to 5, and once you are giving this, then voltage here become 0 for 15 degree. Okay. Now, then again we have to see this commutation between that is over. Here the commutation between your 2 and 4 is over. We are having 3, 4, 5, and then already I said this here this we are going to have the voltage, output voltage, then is the output voltage is minus 1.5 EA, and this will be your nothing but here. So, we are going to have this suddenly, and finally, it will go for 45 degree here till this value, where we are giving the pulse 6. Once pulse 6 is given, then we are getting again here, this will be 0 for 15 degree, and then it will be, you can see again we are the voltage here, it is your plus EC. Yeah. So, it will be here, and then it is coming to be your this one, and then again here we are giving pulse to 1, and then it will be 0 here, and again I can see your output voltage will be like this. This will be here, it will be drawn. So, it will be output voltage here, and then again it will be going like this. Then it is 0. Here we are giving the pulse to 2, and then we can come back this side because the 2 will be there, and then again it will follow here the voltage like this, and here the 3 is given the pulse, and it is 0. So, you can see it is again we are coming back here 3, where before that it was conducting your this case. So, your voltage was like this, and we were getting this output voltage. So, this is you can see the symmetrical DC output voltage in the case of rectifier. So, you can see the 0 and always we are getting. So, even though this is simpler than 2-3 valve conduction mode, because there are so many dents were appearing. So, the voltage wave shapes are even the easier, you can say most of the here is a 0, or you are getting 1.5 times of phase voltage. But in 2-3 valve conduction, even though that pattern, so many patterns we are getting, sometimes dents, sometimes even though different type of jerks were there. Now, to draw here the valve voltage, you can say most of the time it is 0. Only during 3 values it is not 0, otherwise it is 0. So, we can start further drawing the valve voltage, means here I can just draw just below line, this will be the valve voltage I can say. So, it will go up to when your this 4, 5, 6 means 6 is getting pulse and then still it is going. So, it will be going up to the 6 here and it will be up to this point. So, up to this point the value will be 0. Then suddenly here you can see it is the reverse of this, here it is a negative just below. So, whatever you are having here, it was this value will be going this. So, you are having this voltage and it is going to follow this one and it will go up to this portion and then again it will be 0. Okay. So, it is 0. Then we are going to have another one. This is again opposite to this, here opposite to do this, and means we are going to have here this value again we are getting here and it is going to be 0 and here we are getting here 0 and finally this one. So, this is your valve voltage. Since here the color we cannot show, so basically it is here you can see. So, this is your valve 3 voltage and the upper portion is your DC output voltage. So, it is a simpler to draw. So, this table is very helpful, especially if you are drawing the inverter operation. At that time this angle, because we are shifting angle far off, because this is here we are starting, now we are starting at the somewhere here. So, everything mixed up. So, this was the case for your rectification operation. Now, here we can go for our another one case. We can go for the inverter operation, and in inverter here I can here in inverter this will get the different shape. You can see in the rectification, even though it is a 45 degree and you use this, output voltage is very near to 0. But now if you are going inversion, what will happen? The voltage is going to be more and more negative. So, in inverter operation, let us take alpha is your 150 degree and your U is we can keep 75 degree, and then we have to start here. So, here this will be changed. In this case, what happens? Your 3 valve and 4 valves, this is your again 15 degree and this is again it's a 45 degree. Now, we can write clearly this what will be the voltages and what will be your angles. We can just draw here in this table, and since the pattern will be the same and we are going to draw for one cycle, so this we can keep intact. So, now here we are going for alpha 150 degree. We are starting from 150 degree and then we are keep on going to add. So, this is 165. What will be output voltage? It will be 0, because for valve always it will be 0. So, it will be 165, then it will be your 210. Here we are going to have 210, it is 225, then it is 225. So, we are going to have 270. Just check it whether we are going in right direction or not. So, 285, here from 285 plus add 45. So, it is 230. 330, yeah, 330. So, we are going to 330, then 15, 345, then we are going to have 345 to 390, or we can go back and then we can see, or here because this is a 360 plus 90 degree. So, I can say simply it is 30 degree, because after 360 again we are going to back here. So, here from 30, now we can add this 45 degree, and from 45 to here 45 it is 90 degree, and from 90 here is 105, and from 105 we are having 150 degree. you can see we have reached here again. So, we can write the output voltage here. Whenever we are having 4 valve conduction, it will be 0, it will be 0, it will be 0, it will be 0, it will be 0 here. Now, when 1, 2 and 3 are conducting, then your voltage will be again same voltage, because it is not going to change. Only we will see that voltage will be delayed and the output voltage will be negative side. So, here whatever we wrote, it will be the same. Here it is what we wrote here, it is a plus 1.5 EB, here 1.5 EC, here minus 1.5 EA, here we wrote 1.5 EC, here it is 1.5 EB, here plus 1.5 EA. And the voltages here, this is the 3, we are drawing 0, 0 till it will be here, it is a 0. Here we are this one. Now, only once we are here, then voltage will be here minus 1.5 EC, here it is 0, plus 1.5, it is your EB, here 0, minus 1.5 EA. So, with this inverter operation, let us draw, and you see that we are getting something different output voltage here. It is, and let us see for this case as well. So, here again we have to mark here line to line voltages, and the line to voltages here I am starting here with EBA, here I can write ECB, here I can write AC, here I can write EBC, it is it is ECA, here it is EBC, and here it is AB here, and here we are getting EBC, and here we are getting EBA. These are again EB sorry, here we are getting EC, here it is your EA, here it is your EB again, means here we are getting minus EA, here it is what, it is a minus EB, here we are getting minus EC, and here this is your minus EC. So, once we have marked here the below figure, we are marking the phasor voltages, and here we are drawing the line to line voltage, and now for this case we can draw our this inverter output voltage. We are starting from here, again angle here, and we are going up to 150 degree, alpha is delayed. You see your, this is your 150 is somewhere here, just see here your, this is your alpha. Because we are having this 20 here 60 degree, this is a complete EBA is the commutation voltage of valve 3, this is 60, this is 60, 120, and this is the 60, then 180, half of this is 30, so 150 degree. So, valve 3 is given the gate pulse here, and then it will conduct, because the voltage across the outgoing valve across this will be positive. So, we are giving here valve 3 voltage. Once we are giving valve 3, then we have to see where is your 1.5 EC. 1.5 EC was somewhere here, it was starting, and it was here 1.5 here, and it is going all the way here. So, once it is 3, it is given pulse, the output voltage will be 0, and it will go for 15 degree here, because I said it is 15 degree here, it is 0. So, the 15 here, it will go up to this half of this, so it will be 0. Okay. And then it will be, once the commutation is over between 6 and 2, so output voltage will be 1, 2, 3, and we will going to have our output voltage here, certainly here. So, once the 3 here, as I said, the gate pulse is given, so it will conduct at 150 degree, because the voltage across this is positive, and then it will go up to 15 degrees when the 4 valves are conducting, that is 6, 1, 2, 3, and there will be after 15 degree, this there is a commutation between 6 and 2 is over, then 1, 2, 3 will be conducting and the output voltage will be here. This is your, it will go, and now it will go for 45 degree. Now 45, you can see this was the 15 degree here and the 30 degree here. So it will go up to this portion here, where we are giving the pulse to valve 4, and this will be your output voltage. Now once we are giving the gate pulse to 4, output becomes 0, and then it will go back again 0 here, and this will be 0 for 15 degree. Then the commutation here is over between your 1 and 3. Now the 2, 3, 4 will be conducting, and the output voltage will be suddenly, it will be your 1.5, here we are here 1.5 EB, and we have to see 1.5 EB. The positive one will be your, it is going all the way here. Here. So it will be coming suddenly here, and then it will follow, this is your, and again it will be up to 45 degree, when here this is your, it will be your gate valve 5 will be given the gate pulse. So once 5 is there, then the 4 valves will be conducting, and that is your 2, 3, 4, 5, and the output voltage will be 0 for 15 degree again here, because the 4 valves are there. Then it will be, the commutation is over between your 3 and 5, your 4 and 2 is over, because 2 is going. So we are having 3, 4, 5, and the output voltage is 1.5 minus 1.5 EA, and you will find this is here, and this is your voltage that is going all the way here, and we are going to have this one. So it will follow suddenly here, means this voltage is 1.5 EB, that is a plus. This voltage here is minus 1.5 EC, and here we are going to have this, and this voltage is your 1.5 EA is minus voltage here, and then we are giving the gate pulse at this point to your 6, and then this will be 0 here, and it will go for 15 degree again. So we are going to have a very symmetrical pattern in the inverter operation as well, and now here the output voltage will be here, it will be coming all the way here, then it will go up to this, where 1 is given gate pulse, and then it will be again going to be 0, then the voltage here will be again here. So you can see this is your inverter output voltage, and you can say mostly it is negative side. Similarly, we can fill this side also, and we are going to have here, it will be going up to this, then it is going up to this period. Just we have to mark here, and then we will find it is coming all the way here, then this is 0 up to this portion, and then again we are getting this output voltage. Here we are also getting this, and here we are again getting this output voltage. So this is your inverter. You can see this is more negative, even though alpha you can see here the beta is 30 degree, and in 30 degree you can see it is highly negative. So the inverter voltage is basically increasing, but your rectifier voltage is decreasing. So both are same thing, and you can see this is your valve output voltage. This is not valve, this is the DC output voltage of this. And valve voltage, as I said, most of the time it is 0. So it will be 0, and whenever it is there, it is just output negative of the output voltage. So I can draw the output voltage, valve output voltage here directly, and again we can start from here, that is the 3, and it is going all the way up to when the 6 is getting pulse, means it is going to be 0 here up to this is valve voltage, and once even though 2, 3, 4, 6 are conducting, it is 0. So it will be going up to this portion as well. Now means I draw up to here when 3, 4, 6, because 6 is getting pulse, and for this duration again this 3 is there, because the commutation between 3 and 5 is over now. So, we have reached up to here. Now, we will find 1.5 EC the positive side. Here you will find this is your, this will be, I can again write here what is this value. This value is your plus 1.5 EC. So, the voltage will be somewhere, it is just reverse of this, we are having this is a minus EC, you can just see. So, it will be following here and it will be going up to this when it is. So, this is your valve voltage, and once it is again here it is 0, then we are going to follow another one, and here again it is your valve voltage, it is going, and finally again it is here 0. Then we can come this side, because before that here it was 0, now is a 3, here it is your 2, here it is your 1. So, we have gone even though the 6, we will find up to 6, then 1, and we can again the repeat basically, and then we will find this what will be the output voltage. So, we are having the 3 output voltages here, and again then we are repeating here, because even the 1 is given, the 3 is 0. So, 1 is given, the 3 is 0 of course. So, we can get the output voltage even though for here it will be 0 here again. So, means it is 1, here it is your 2. So, you can see your just above 1 we are going to have this output voltage. So, 1 is fire, so this is 0. So, we are going to have basically this side also we can repeat, here it is 0, and then again here we are getting this output voltage. So, you can say 1 is starting here, means 3 output pulses here in this cycle we are getting, means in the complete cycle here again just 1 is coming here, means we have reached here, and then we are having 3, and already here you can see the output voltages are 3 times there, and remaining time it is all the way 0. So, this is valve voltage which is appearing across the valve 3. Similarly, you can draw for other as well. Well, now let us go for here to calculate the current in the during the different, here you can see the 3, it is going to be different fashions here, the 3 is coming all the way up to here from starting from here. So, here the commutation between 1 and 3 is taking place, here also 1 and 3, here also 1 and 3, and now it is over. So, at this point once it is starting here, the current in the 3 is going to be complete ID, because this 3 is only on the upper limb. So, the complete current the valve 3 is taking. So, we can see there before that here again 1 was carrying the complete current. So, we are having the 3 the modes, this condition and this condition where the commutation is taking place, means the 3 intervals are there where the different scenarios are there, and based on that we have to derive this what is the current, how from 1 to 3 is shifting in all these 3. No doubt you can see this is going for the 15 degree, or again it depends upon what your u and other values, and we can just start with this. So, to have this here, now I have similarly here you can see I have written that is your this period. Now, we are not going for any either rectifier or even your converter rectification operation or inverter. Here simply we can now see starting with the general expression we are drawing. So, I can say this is starting alpha to your omega t to your certain value, and this value was your, it is your alpha plus u minus 60 degree. So, it is your u minus 60 degree will be there, means you can just subtract this minus this, that is the degree, that is a 15 degree we also calculated. So, this will be the phase when 6, 1, 2, 3 will be there. Now, this phase will start your alpha plus u, all the time we know it is delta. we defined this alpha plus u as a delta. So, I can write the delta here, or you can start with alpha plus u, no problem. So, it is minus 60 here, this will be the current will change, and now it will go for alpha plus 60, because the total duration here is at 60 degree. Now, this phase is your alpha plus 60 omega t. Here again we are going to have this, we are going to add alpha plus u, that is all, because this period is your u minus, just simply add u minus 60. So, this will be alpha plus u, and here, and then of course, we are going to have alpha plus u, we are again repeating basically, and your omega t here, this is your, you add just delta plus your u minus 60. Means our concern here, because this is at this end of this period here, this 3 is going to take complete ID. Means here this your complete ID is equal to your I3. During this one, it is shared by I1 and I3. I1 is the valve 1 and the I3 is the valve 3. So, this is the diagram, and already the different the commutation period here is written. So, who is sharing, and this is the case. Now, we are going to analyze this case first. Means this is the case when you can say your 6, 1, 2 and 3 are conducting. Only here you can see the current between this and this, here you can apply the Kirchhoff's law. So, this current which is coming here, it is, and plus this will be this current. However, the current here in the phase will be equal to the valve phase current. Here the current here will be the negative of this valve 2 current, because we are assuming the currents are coming all the phases, this IA, IB, IC. So, to start with, we can from this circuit we can write the voltage equation, that is always valid. The voltage equation here, EA minus L di upon dt will be equal to this EB minus L dIB upon dt, and this will be equal to this voltage, because during this it is 0. So, this is all 3 are the parallel. So, the mathematical equation we can write like this. Here I wrote the parallel equation here, this EA minus L dia upon dt will be equal to your EB L di by dIB upon dt, and similarly we can say the phase A side will be equal to phase C side. Just add these two equations, we are going to get this. Once we are getting this, we can substitute here. So, this is equal to your plus EA, because minus EB minus EC is plus EB. So, it is 3. Here we are adding, because it is a 2L di by dt, here again you are adding, you are getting 3L dia upon dt. And finally, we are getting the dia dt is equal to nothing but it is the valve 1 current. And we know this valve 1 current and the valve 3 current, addition of this is all the time it is ID. So, again here we can this using this relation, that is your I1 plus I3 is your ID all the time. So, here again I can say I1 over dt will be equal to minus di3 by dt. Small quantities I am writing because it is instantaneous right now. So, here I have written this relation here, and this is equal to your EA, and EA again we are writing because our reference was EBA. Based on that, here means it is your under root 3 EM sin omega t. Based on this, we can write the voltage EA will be this. To draw this the voltage, sometimes suppose you do not want to remember here, just I said your we took this is your we are taking this is E this is your EBA, if you remember, because this is your, here simply draw this. This is your, it's not very nice curve, but still we can draw. This is your this. So, this is your EB, here it is your EC. So, this angle here it is going to extend it. So, this angle is 150 degree, and that is why it is written omega t 150, and since it is leading, so it is a positive, because this is just behind with the EBA. So, I wrote this, and now you can write with this expression, you can just simply integrate and you can get your I3. Now, here this I3 is your expression we are getting. Now, this period is between these period. So, using this period here you can see this is the general expression with omega, and now this we can write this expression with omega t. We have derived starting from here to your omega t here, means you can see simply it is a sign is integrated. So, it will be cosine with the minus sign, but this minus is going to be positive. So, it is a cos omega t plus 150 degree minus cos alpha, because we are integrating from alpha to omega t. So, here we are getting cos alpha plus 150 degree. This can be again changed, because the 50 is equivalent to this, you can write with the minus omega t minus 30 degree. So, here I have written with the minus, and this minus becomes positive, we can write here in alpha. Why I am writing here? Because if you see this, our output voltage was in terms of cos alpha minus 30, and also the delta it was plus 30. So, this will see it is nothing but alpha prime. Alpha prime is equivalent when we are going alpha, when I am using the 2-3 valve conduction, then alpha prime it is your 3-4 valve conduction. So, we are going to have the similar expressions. So, this is your I3. Now, at the end of this here, this phase, now we are coming here. So, and if you are putting this value here, omega t is equal to this will be the starting current of this. So, that is why here it is written, if at omega t is equal to alpha plus u minus 60 here, this will be the initial current of this, and then we have to integrate for this period. So, here your I3 here at this period, just put this value, you are going to get this expression. So, this is the case when 6, 1, 2, 3 are conducting. Now, next phase is your here when, as I said here, 1, 2, 3 are conducting, this is starting from here to here. This is the similar when we derive the commutation between 1 and 3 for the 2-3 valve conduction mode. There is no change, only the period is shifted, and during this period it is following the same expression. And we derived here, we are getting this EBA upon 2L at that case. So, you are going to integrate this I3. If you are going to get I3, means you have to integrate from the initial value of this to this some omega t, and we are adding plus I3, because this I3 here was flowing in the beginning. So, the integration, the initial current is going to be added. So, this I3 here we are adding, and then this is a normal expression for this mode. So, here if you are simplifying and putting this value from the previous one and simplifying here all the way, you will find you are going to get the current this, and again I want to know what will be the current at this value, because that will be the initial current for this phase. So, the initial current for this will be at this point, you just put this value then and add it. Here you are deriving the expression, you are adding here, after that you are getting the current here, that will be the initial current of this phase, means we are having the 3 stages. The commutation is taking place, and if you are putting this value, you are going to simplify, you are getting this I3 at this point. So, it is you are getting, now you can see we are getting alpha cos alpha minus 30 plus half of the cos delta plus 30. These are the expressions we were getting in the output voltage as well, means is alpha minus 30 and here the delta plus 30. We are getting another term minus under root 3 by 2 cos alpha plus 60 here in this case, and but here you will see the magnitude is also changed. When we were talking in the 2-3 valve conduction mode, the commutation here it was basically under root 3 em upon 2 omega all it was coming. So, we will just for next phase here, as I said, it is a initial voltage here and it is 1, 2, 3, 4 are conducting. In this case again, now you cannot take this expression, because if you see in this case what is happening, the current here your one here this 4 and here A are their sharing, means at that point what is happening, the current which is flowing here is I A, it is your I 1, this is also conducting, this is giving your I 4 current. So, what happens here in the previous case, we took this, if you remember, I A is equal to, it was I 1, in that case it was the case the first phase here, because it was only one was there and thus completed the phase was current. So, this at that time it was not conducting, so this current was equal to this current, but now in this phase it is not true here, because this is basically the here again Kirchhoff's current law applies. So, what we will do, we will see which is very clear, and you will find this in this case here, this is your current here I B, it is your going to be here I 3, it will be equal because 6 is not conducting. So, we have to change our formulation, that is why earlier you will see I was talking here E A, E B, here now I have changed from E B and E C, earlier it was E A. So, what we will do, we will derive this expression again on the in the next lecture, and we will derive, and then finally we will see what is the relation between your current and the voltages. Basically, we will find the final current will come from this value. You can see this is a similar to the voltage equation, and then from this we will derive our again in terms of commutation resistance, and your ID current we will see on the next lecture. So, thank you very much.